viewers, welcome back to my channel. In this video I am going to discuss one of the important theorem. Okay, if p is a prime number, then prove that square root of p is also irrational. Okay, I am going to prove this statement, okay, by using the contradiction method. Okay, contradiction method is we have to take opposite of the given statement. Okay, here given that square root of p is irrational, I am taking here opposite of this statement. That means I am taking square root of p is a rational number. Let square root of p is rational. Okay, that means if it is a rational, we can express square root of p as a by b form. Okay, a by b is a simplest form. Okay, it is a simplest form. It is a simplest form. Simplest form nothing but a and b are co-prime. Okay, and b is not equal to 0. This is our assumption. Okay, we are assuming that a and b are co-prime. Co-prime nothing but a and b does not contain any common factor, any common factors other than 1. This is our assumption, other than 1. Okay, this is what we are assuming. Okay, next step is squaring on both sides. Squaring on both sides, we get square root of p whole square is equal to a by b whole square. Okay, square and root get cancelled, we get p, that is equal to a square by b square. Okay, next I am going to do, I will take cross multiply this b square here and I will take b in denominator. Okay, that means I can rewrite like this: b square is equal to a square by p. Okay, we know that one of the important result, okay, important result, we know that if p is a prime number, okay, wait, if p divides a square, that implies p divides a, okay, where p is prime number and a is positive integer. Okay, positive integer. Okay, this is the most important theorem I am going to use here. Okay, next step is, see, I am going to use this result here. If a square divisible by p, that means p divides a square, that implies p divides a. Okay, that means I can express a as, okay, prime into some positive integer. Okay, where k is positive integer, because see, because a square divisible by p, that implies a is divisible by p, that means a contain a, okay, one of, we can express, we know that every integer we can express in the form of prime. Okay, product of primes. Okay, yes or no? A is a positive integer, that means if a is divisible by p, that means I can express a as some prime into positive integer. For example, if I will take 16, I can express 2 into some 8, 2 into 8. If you observe here, 2 is also a factor of 16 and 8 also a factor of 16. That means 2 also divides 16, 8 also divides 16. Okay, here 2 is a prime number, 8 is a positive integer. Okay, that means I can express a is in the terms of prime into positive integer. Is it clear? Okay, that means here P is a factor of A. Okay, is it clear? Okay, thus P is a factor of A. Okay, similarly we can do this as, we can take this as equation number 2, take this as equation number 1. Okay, put A value in, okay, put 2 in 1. Okay, that means replace A value in place of 1, we get B square is equal to, in place of A replace PK, okay, square by P. Okay, that implies B square is equal to P square by K square by P. Okay, 1P get cancelled, we get B square is equal to P into K square. That means if I will divide P on both sides, okay, we get B square by P is equal to K square. Similarly B square is divisible by P. That means if B square, that means P divides B square, that implies B divides B. Okay, that means let I can express B as in terms of prime into any positive integer. Okay, where M is positive integer. Okay, that means what? P is a factor of B. Okay, yes or no? That means, okay, we assumed that A and B are co-prime. That means A and B does not contain any common factor, but if you observe here, P is a factor of B and P is also a factor of A. Okay, that means thus P is a common factor of A and B, okay, but this contradicts the fact that A and B have no common factor other than 1. Okay, that means our assumption is wrong. Okay, what we assumed that A and B does not contain any common factor, but we showed that B is a common factor of A and B. Okay, that implies our assumption is wrong. Okay, therefore okay, you can use ends. Okay, ends, you can use ends square root of P is irrational. Okay, this is the general proof of the square root of P. Okay, in place of P you can take root 2, root 3, root 5, root 11, okay, and so on. Okay, you can take, in place of P you can take any prime number. Okay, process and process of proving is same. Okay, I hope you enjoyed this video. If you liked this video, please subscribe my channel and support my channel. Okay, thanks for watching. Jai Bhuneshwari.